Went too far. There it is again, at 26.3807. These two tests were exactly the same as those printed out for the 2x2 table. The p-values are exactly the same, less than 0.001, meaning that now you have another way of doing a test of significance for a 2x2 table. You fit a logistic regression model with a single variable, x1. 1 is if you're in the first row of that table, 0 if you're in the second row. You'll get the same chi-squared test labeled as the score test. And if you want, you get a likelihood ratio test, something we'll be talking about next week. This tends to be actually a better test to what the likelihood ratio test. It's going to be linked to this number up here, this -2 log L, this model fit statistic. Because if you subtract 1351, if you subtract 1324 from 1351, that's where that number 26.38 comes from. So next week, we're using this -2 log L as a measure of how well our data is fitting, how well our model is fitting a data set. We'll be looking at the drop in the minus risk factor that contains only the intercept. That's the null model that says everybody has the same risk, everybody has the same odds of getting disease, everyone has the same log odds, namely B0, versus a model that contains the risk factor of interest, the intercept plus x1. The intercept-only model is the model that's true if the null hypothesis is true. The intercept plus covariance is the model if the alternative hypothesis is true. And the difference in the -2 log L is going to be used as a test of significance. We'll talk much more about that next week. But realize all we've done so far is to show you that for a 2x2 table, if you fit a logistic regression model containing only the row variable of that table, more importantly, you get the same odds ratio. The coefficient of male is 0.7070. Remember, that's the log odds ratio. You turn that into an odds ratio, you get the same odds ratio we had before. And the confidence interval we get is the same confidence interval we got before. 2.028, 1.543 up to 2.665. If we go back to the 2x2 table that we saw initially, there's that same odds ratio. There's that same confidence interval. So bottom line is, anything you can do with the 2x2 table, you can do with the logistic regression model. So if you have a binary risk factor and a binary outcome, you can build 2x2 tables, or you can build logistic regression models and get the same inference, the same p-values, the same confidence intervals, the same odds ratio. If you have more than 2 rows to a table, you have a categorical outcome like PAX. What you can do is build a model not with a single risk factor, but 3 risk factors. PAX1, PAX2, and PAX3 are all in the model. PAX1 is an indicator variable to indicate whether you're a 1-pack-a-day smoker or not. PAX2 is an indicator variable of whether you're smoking 2 packs a day or not. PAX3 is an indicator variable of whether you're smoking 3 packs a day. So the general rule is if you have 4 levels to a categorical variable, you need to include it in a model with 3 indicator variables. This is nothing different from the general rule we had from male in the previous exercise. Go back to that first model we looked at. Notice we have in the model a single variable, 1 if you're a male, 0 if you're a female. I don't also have to add another variable, which is 0 if you're a male and 1 if you're a female. I don't need to include an indication for female, because once I know your male status, I also know your female status. It's redundant information. I only need to include 1 of the 2 indicator variables when I have 2 categories of a risk factor. When I have 4 categories, I need to only include 3 of them, any 3. Because if you're a 0 for PAX1, then you're not a 1-pack-a-day smoker. And if you're a 0 for PAX2, you're not a 2-pack-a-day smoker. And if you're a 0 for PAX3, you're not a 3-pack-a-day smoker. So you have to be a non-smoker. So the other category, the non-smokers, are people who have zeros for all 3 of these factors. But what do these numbers, B1, B2, B3, represent when you have 3 indicator variables? The model itself, if you were a 1-pack-a-day smoker, you were a non-smoker, your values for PAX1, PAX2, and PAX3 in the previous model. You're 0 for PAX1, you're 0 for PAX2, you're 0 for PAX3. The model says your log odds of disease is just B0. So a non-smoker has a value from this model just being equal to B0. A 1-pack-a-day smoker gets a B0 plus he's a 1 for PAX1, so he gets the B1 term. A 2-pack-a-day smoker, if I go back to the previous slide, is a 0 for PAX1, he's a 1 or she's a 1 for PAX2, and a 0 for PAX3, so she or he gets a B0, doesn't get the B1 because PAX1 is 0 for that 2-pack-a-day smoker, but does get the B2 because PAX1 is equal to 1. It doesn't get the B3 because PAX3 is equal to 0. So what that person gets from this equation, from this model, is a B0 plus a B1. 2-pack-a-day, that's what a 1-pack-a-day smoker is. A 2-pack-a-day smoker gets a B0 plus a B2. 3-pack-a-day smoker from the model gets a B0 plus a B3. So if I subtract the top equation from, say, the first equation, the second equation, the B0s cancel out. B1 becomes the log odds ratio comparing a 1-pack-a-day smoker to a non-smoker. B2 is the difference between this equation and the top equation, so B2 is the log odds ratio comparing a 2-pack-a-day smoker to a non-smoker. And B3 is the log odds ratio comparing a 3-pack-a-day smoker to a non-smoker. So knowing that, what happens if we fit this model? The model again says the log odds of developing new CHD is B0 plus B1 times PAX1 plus B2 times PAX2 plus PAX3. What do we get from SAS for an output? We get some model fit statistics. We get some tests for the null hypothesis. Notice this score test, 8.7710, with a value of 0.0325, is nothing more than the chi-squared test of association we got back on the original 4x2 table. I'm trying to go back to right now. So, the computer is getting tired, so that's why things are not going so. Here's your 4x2 table. If I did a regular chi-squared test, 8.771, p-value of 0.0325, that's exactly the same as the score test we just looked at in the logistic regression model. The likelihood ratio chi-squared test, this 8.17 will be the value for the likelihood ratio chi-squared test from the model. So again, for a 4x2 table, this is nothing more than building a model with 3 indicator variables to represent 3 of those 4 rows. More importantly, before I go back to the model, remember the 3 odds ratios, each of them comparing a level of smoking to the non-smokers, 1.169, 1.914, 0.705. When I fit my model, let me go back to my logistic regression model. Remember, there's that same chi-squared test of association, p-value 0.03. There's that likelihood ratio test we saw from the 4x2 table. And now, notice these are the coefficients, of PAX1, PAX2, and PAX3. These are all log odds ratios. If we turn them into odds ratios, we get the same 3 odds ratios we had before when we manually, by hand, divided the odds of getting disease for a 1-pack-a-day smoker versus the odds of a non-smoker, or a 2-pack-a-day smoker versus a non-smoker, or a 3-pack-a-day smoker. Notice there's that seemingly protective effect of heavy smoking, odds ratio of 0.705, but notice its confidence interval. It goes from 0.15 up to 3. So it contains the null value. The value 1 is in this interval, so the data does support the null hypothesis that 3-pack-a-day smokers and non-smokers have the same risk, the same odds. It also supports a very protective effect that 3-pack-a-day smokers' odds are 0.15 times that of non-smokers, but it also supports a very harmful effect that 3-pack-a-day smokers have 3 times the odds non-smokers have between these. So this very wide confidence interval is reflecting the small numbers of people in the heaviest smoking group. And next week, when we talk about these printouts in more detail, notice there's a p-value on the line for PAX3. The p-value here, 0.6479. That's the p-value you would get if you built a 2x2 table only comparing the 3-pack-a-day smokers to the non-smokers, and asking, do they have a significant difference or not? And it doesn't, a non-significant p-value, because of the small number of heavy smokers. So there was no significant difference between the lower risk of heart disease among the 3-pack-a-day smokers and compared to the non-smokers. And that, again, is reflected by